My name is João Alves. I was a Radcliffe Fellow 2018-2019. I came to Radcliffe to make a map. I did find many things. I found things I was not looking for, and I found things I didn't know I was looking for. Thank you.
I'm Alyssa Goodman. I'm a professor of astronomy here at Harvard.
She's a world leader, and she can see things that few other people can.
A few years ago, I was lucky enough to be a Radcliffe Fellow, and after that, a co-director for science at Radcliffe.
My project, when I came to Radcliffe, was to make use of a large database, a new database from a new satellite, a European satellite called Gaia. I was lucky to find people at Radcliffe, at Harvard, that were very interested in helping me, and that turned out to be the reason why we discovered the Radcliffe Wave.
There's another person who's on the Radcliffe Wave paper who's really key to the technique, who's Doug Finkbeiner. And Doug and I were sharing this very smart graduate student at the time, Catherine Zucker.
Catherine was working on a method, a wonderful method to determine accurate distances to clouds.
And I was working on this with another PhD student in Doug Finkbeiner's group. His name is Josh Spiegel. And essentially the 3D decimal mapping pipeline that we built together, it improved our understanding of where these stellar nurseries were by a factor of 10, essentially overnight.
I was suspicious that there was what we called later a ramp between a cloud that's off the plane and a cloud that's on the plane, and then maybe there's a trail between them. And I asked Catherine to actually figure out the distance to these clouds. And she did, and there it is. It was kind of a ramp. I remember being so excited about it, but I also remember people saying, "You're nuts."
And one of the things that happened was João and I got to give an astronomy presentation about the astronomy of the famous Radcliffe astronomer, Henrietta Leavitt. So around the turn of the 20th century, there was a big project to map the entire sky, carried out at the Harvard College Observatory. And there was so much data, which is on these glass plate images of the skies. And there are 600,000 glass plate images of the sky that cover 100 years. So this is still a tremendous database. But they had so much data that they didn't know what to do with it. And so the directors of the observatory at the time realized that there were many very talented, educated women in Cambridge, and they hired them as quote-unquote computers, human computers. And one of those women was Henrietta Leavitt, who was a particular genius and who made all kinds of discoveries on her own. And particular thing she's famous for is now pretty much renamed Leavitt's law, but is sometimes called the period luminosity relation. And that's what you need to put into what Edwin Hubble found to understand the expansion of the universe. And so Hubble could not have done what he did without Leavitt's law.
Now, and this is where the Radcliffe moment enters, is that I've been seeing these beautiful quilts by the artist Anna von Mertens. It was a work on Henrietta Leavitt. And what she did, she stitches. And she had these two beautiful pieces of art where she tracks on the sky the day Henrietta Leavitt was born and the same stars on the day she died. And I was mesmerized by it. First, because I have no contact with artists before, or apart from the normal contact with art. Why? Why would she do this? And I remember passing by, going to lunch, and what is art? What are these people doing? Why is it so different from everything else? I mean, I was mesmerized by that. It was beautiful, piece two.
So it was such a privilege to be here at Radcliffe during the year that the Radcliffe Wave was discovered. And I really got to see not only the discovery itself, but the construction of that discovery, the step-by-step process. Because after João and I met at my opening, we just would have coffee. He would show me what he's working on.
And I remember taking pictures with my phone very close to them. And I see the stitch kind of going down and up and down and up, which then translated for me as the plane of the Milky Way. And that maybe that ramp, it could be more than just a ramp. And just like a stitch on the cloth, I want to credit this moment, this work from Anna as the trigger that led me to think that, yeah, we should look then the other way. The ramp is there, but if this is a stitch, then I should look up and then down and all that.
It was such a delight to see João step by step respond to the data, ponder, think, and then this sort of toggle between theory and observation and how that step by step built something.
So he called me up. It was a Friday night. He said, "Where are you?" And I said, "Oh, I'm in my office." And he said, "Can I come show you something?" And I said, "Sure." So he comes over, and on the way we realized, well, we better invite Catherine, and we better order Indian food.
We didn't go home. I said, I have something, you just don't move. And we ended up until midnight plotting all kinds of different visualizations of the data.
And at one point I went, oh, wait, we should just put this in worldwide telescope. And we just literally drag the data onto this window that can show you the data in context in the galaxy. And suddenly we went, oh my goodness, here's the plane of the galaxy, here's this thing, and it's sticking way out of and it's lined up with where they thought it was going to be. And I'm like, oh my God.
That cloud there, I'm going to predict it's going to be that distance because, it follows the stitch.
Then what happened was, because people, including me, were very skeptical, and so it was really Catherine and Joao that kept mapping the distances to more and more points.
I'll never forget the time that Joao and I spent in his fancy office at Radcliffe, where he would be like, Catherine, look at this region, look at this stellar nursery. I predict it's at this distance because this would help me form this wave. And I was like, I don't know, Joao. And then we looked at it and I was like, Once we got halfway reconstructed, though, then I was on board.
And the rest, as they say, is history.
Because I was at Radcliffe, because I had all the conditions for this to happen, I think it would be a very suitable little homage, not only for the Institute, but for all the work of Anna von Mertens, Henrietta Leavitt, and many women that work at the observatory. They were graduates of Radcliffe. So I felt this is the Radcliffe Wave. There's no other way but the Radcliffe Wave. And I'm very happy that I chose that name.